So we started with this topic yesterday, and we were just revising the questions. So here's this question which we were doing yesterday, and I was not able to discuss. So please answer this. For a convex hexagon, what is the maximum number of points of intersection of diagonals inside the hexagon? Don't do any mistake. Don't misuse P&C. Don't misuse P&C. I'm sure you must have solved this question. Tell me the answers. Kavya says 1. Why 1, Kavya? There would be many. Good evening, everyone. We have Maheshwar, Zinab, Abhilya. What is that? Abhya, I guess. Sorry, Abhya. So answer is Harsh is 5. Shubhangi 13. कैसे आया 13? Shubhangi 13 कैसे किया? Harsh, how did you get 5? 62. Kanishk says 62 कैसे आया? By the way, 62 is 15. हाँ, Nishtha also says 15. कैसे आया 15? आज हमारे यहाँ बिजली नहीं है. आपके यहाँ बिजली नहीं है, then at least you can witness the class. You can attend the class. कल हमारे यहाँ इन्वर्टर उड़ गया था. That's why it was not possible. Yes, I'm on site, please. I drew the diagram and made diagonals go 13. Shubhangi, you may have drawn a regular hexagon. No? It is not necessary to be regular. That's why it is asking about maximum number of points. Maximum number of points. Nishtha says 64. Good. Earlier somebody says 62 also. Kanish is saying 6 corners and 2 points per diagonal. इसका क्या मतलब भाई? There are 6 points and we are not looking for the diagonals. We are looking for the points of intersection of the diagonals. We are not to count diagonals here. We are to count intersection of diagonals. Okay. Now listen carefully. By the way, Nishtha has mentioned perfectly fine. Nishtha, can you mention why 64? That is the right answer, by the way. Can you mention how did you get 64? Shubhangi, irregular hexagon means which is not having equal sides and not having equal angles, isn't it? There can be many. 15 or 64, that is the right answer. 24 is not correct, Preeti. Aditya, wo chance ki baat hai, 62, 64. 62 reasoning was not correct. Kanishk was mentioning 6 corners, 2 points per diagonal. That reasoning was not correct there. Yes, Nishtha, that's perfectly fine. We need 4 points for 2 diagonals to intersect. Excellent, that's correct. Now listen everyone, please listen everyone carefully. Don't fluke. That's why I said don't misuse P&C. I know that you know the formula. You know the formula of NCR. हर जगह चिपका सकते हैं ना, कहीं भी उठाओ NCR लगा दिया, कहीं भी लगाओ R factorial. But that is misuse. See, try to understand now. It is intersection of diagonals. So intersection of diagonals, we are having 6 points. So let's say point number 1, 2, 3, 4, 5, and maybe 6. Okay? Now this shape is not a regular hexagon, right? If I will join them, this is not going to be a regular hexagon. So diagonal means which is a line segment which joins non-adjacent vertices. साथ वाले vertices को छोड़ के if I draw any diagonal, that will be known as diagonal. That line segment will be known as diagonal. So suppose if I join these two, that's a diagonal, fine. And same way if I join these two, so both of them are diagonals and they are intersecting at one point, right? Both of them are diagonals and they are intersecting at one point. So this is one point formed by intersecting of the 2 diagonals, and it is inside this hexagon. Fine. Hexagon would be by joining these all vertices. So this is one such hexagon, one such intersection point. So question was, for a convex hexagon, what is the maximum number of points of intersection of the diagonals inside the hexagon? We want to have maximum such points. See, by intersecting 2 diagonals, there is going to be always one intersection point. One thing. Next, not every 2 diagonals will make an intersection point. This is one diagonal. अगर मैं दूसरा diagonal यहाँ पे बनाता हूँ, let's say this one. This was a diagonal. This is also a diagonal, but these 2 diagonals are not intersecting anywhere. They are not intersecting inside. Fine. So to get an intersection point, what do we want? We want 4 vertices. We want 4 vertices of this hexagon, and by joining them alternately in this particular manner, in the cross manner. So इस वाले को इसको एक छोड़ के अगले वाले point से join किया, उसको एक छोड़ के अगले point से join किया. So when we are going to join them in this cross manner, we are always going to get one intersection point. So as Nishtha has mentioned, that is perfectly fine. So we just need to calculate the number of ways, that in how many ways out of the 6 points at the as the vertices of this hexagon, in how many ways we can select any 4 out of them, because every selection of 4 such points will give you one intersection point inside the hexagon. So 64 is the right answer. Okay? And manually also by drawing you can identify, but it will take a long time. 15 is correct, Aarti. Is it understood? Is this point clear? Good. 4 vertex से एक intersection point मिलेगा. Yes, exactly. By choosing any 4 vertices out of the 6 vertices of the hexagon, you just need to join them crosswise, and you will always get one intersection point inside. Exactly. octagon में 8C4 हो जाएगा. हमेशा ऐसा ही होने वाला है. Okay, Pritam is asking, what about 2 parallel diagonals? Yes, they can be 2 parallel diagonals. तो भाई साहब मैंने बनाया ना यहाँ पे. देखो, maybe this diagonal let's say let me use different color, let's say white color use करते हैं. So मान लेते हैं this diagonal and this other diagonal, let's assume they are parallel. So who is saying to use these two diagonals? I'm saying when you have chosen these four vertices, so now these four vertices needs to be joined crosswise like this. And when you are joining crosswise, then always you are going to get one intersection point. Fine. So always when you are choosing four vertices, whether they are parallel or not, so you can get different line segments by joining them. But when you join them crosswise, so those crosswise, they are two diagonals and they are exactly creating one intersection point. So that's how it is 6C4. So by selection of every four vertices, you are going to get exactly one intersection point of the diagonals inside the hexagon. So this 64, which is nothing but 62, that is 15. This is the right answer. Understood? मतलब ट्रायंगल में ये एप्लीकेबल नहीं होगा. ट्रायंगल में कौन सा डायगोनल्स होता है आदित्य? Okay, let me ask you one more question in this. Actually, there can be many things. Let me ask you one more thing. तो out of hexagon की बात करते हैं. Out of hexagon, what should I say? How many triangles can be formed? How many triangles can be formed such that whose one vertex is same as the vertex of the hexagon and the other two vertices lie inside the hexagon? I repeat, by joining the diagonals. Let's say this is a hexagon. 1, 2, 3, 4, 5, 6, something like this. This is a hexagon. 1, 2, 3, 4, 5. अच्छा 5 बना. Let's make it 6. Let's make it 6-sided. Let's make it 6-sided. 1, 2, 3, 4, 5, 6. Okay, I'm trying to make it non-regular. So this is 6-sided hexagon now. So by joining of the diagonals, you are going to get various figures inside, right? Now question is that how many of those figures will be triangles? How many of those figures will be triangles whose one vertex is same as the vertex of hexagon and other two vertices lie inside the hexagon. Is the question clear? हम ऐसी triangles की बात कर रहे हैं by joining this diagonals. तो जिसका एक vertex तो hexagon की vertex ही हो and बाकी दोनों जो vertices हैं they must lie inside. Is that possible? So that's the question here. So don't go about this diagram only. This can be any hexagon. So we are talking about maximum such triangles which we can get. So this one vertex of triangle is same as the vertex of hexagon, and the other two points are getting formed by intersection of diagonals, right? So basically, how many vertices of the hexagon would be involved? That is the point. This one vertex of the hexagon, this is another vertex of the hexagon, this is another 3 so far, 4 and 5. So basically 5 vertices of the hexagon would be involved, and these all are nothing but diagonals. So there can be any one more vertex. So let's say the 6 vertices is somewhere here. So these are the 6 vertices, out of which 5 are involved to create such triangle, isn't it? 5 are involved to create such triangle. See, this was the hexagon here, right? So 1, 2, 3, 4, 5, 6. This was the hexagon, and out of the 6 vertices, these 5 vertices are involved to create such triangle. Fine. So as in earlier case, we found out of the 6 vertices, 4 vertices were required. That's why our answer was 64, because every such selection is going to give us exactly one intersection point. Now in this case, we need to see कि जब हम ये 5 vertices को select कर रहे हैं in 65 ways, of course, तो are we going to get exactly one such triangle or more triangles can be there? There will be more triangles also. There will be more triangles also. How many triangles will be there? With every such selection, there will be 5 triangles. So answer is 5 times 6C5. This multiplication sign I should put somewhat below. This is 5 into 65. That is 30, right? 65 means 6, so 6 into 5 is 30. So 30 such triangles would be there. Why? Because this one vertex out of this 5, which is to act as a vertex of triangle also, it can be either of them. It can be either of them. So इस vertex को triangle का vertex लेते हुए one triangle, इसको vertex of triangle लेते हुए another triangle, and so on. So for every selection of 65, 5 vertices out of the 6, there will be exactly 5 different triangles. So total 30 triangles will be formed in this diagram. Okay? Anyway, starting with was a heavy question, but you just need to understand. You just need to understand what is the requirement. Don't misuse P&C. I'm repeating same thing. Okay, I'm repeating. Aditya. I'm repeating. ध्यान से सुनो. So our requirement was to have a triangle whose one vertex is same as the vertex of the hexagon. It is here, and the other 2 vertices are created by intersection of diagonals because they lie inside the hexagon. ठीक है ना? So फिर ये कैसे बनेंगे? That's how I have drawn it. So this is one side, this is another side, and this must be some third side of the triangle. ठीक है? So and these endpoints must be certainly vertices of the hexagon. So 1, 2, 3, 4, 5. So 5 vertices are involved to create this triangle, as we required, where one vertex of the triangle is same as the vertex of hexagon, and the 2 other vertices of the triangle lie inside this hexagon. So out of total 6 vertices, we always need a selection of 5 vertices which can get us this triangle. ठीक है ना? And next I figured out कि by selecting these 5 vertices out of 6, am I going to get only one such triangle? Then we saw that no, we are not going to get only one such triangle. There will be total 5 such triangles, because this is the one when this vertex is being used as the vertex of triangle. We can get another one if I use this vertex as the vertex of the triangle. Let me draw this another case in here so that you can figure out ये 5 क्यों आया. ये 5 क्यों आया? To understand this, let me draw second triangle possible from the same selection of 5. So 1, 2, 3, 4, 5. These 5 vertices we have selected. ठीक है ना? Now see here. यहाँ पे हमने कैसे बनाया था ट्रायंगल? This vertex was joined with एक छोड़ के अगला vertex, एक छोड़ के अगला vertex. Same way here. So if I join this vertex with एक छोड़ के अगला vertex, that is this one. And same way एक छोड़ के अगला vertex, ये हमने join किया है already. This one. ठीक है? And now these two diagonals are acting as side of the triangle, and the another side is formed by joining these two now. That's it. So now this 1, 2, 3, 4, 5, same 5 vertices we have used, and by their joining, what we have got? We have got this one more triangle, this yellow one, such that whose one vertex is same as the vertex of the hexagon, and other two are lying inside this hexagon. That's the thing. So same way we will get a triangle here also, and here also, here also. So 5 such triangles will be there with every selection. So the thing is 5 times 65. Don't worry. दो छोड़ के ड्रॉ करना तो सेम ही बात है ना? It's same thing. Exactly. 5 points are required to make one triangle. That was the requirement. Okay, let's move further. Don't bother on this point. इसको हम फिर से आगे भी करेंगे. You just have make a note of all these things. Just keep this thing in mind कि कैसे कैसे सोचना है. How we have to think. ये थोड़ा समझ में आया ना? हाँ, don't worry, Aarti, that's fine. थोड़ा समझ में आया, that's fine for now. Okay, let's move further. We will take up the similar question more. Again, you will find more such questions further. Let's move further now. I'm moving to this next question here. Now it is a similar question which we discussed in the first class, I guess. In how many ways can 3 new cars be parked in 8 vacant parking lots if no 2 cars are parked in adjacent parking lots? Please answer this one. Shubhangi, 5 vertices से 5 triangles बनेंगी ना? With every selection of 5 vertices, we are going to get triangle, and with every selection of those 5 points, we can use any one of those 5 points as the vertex of the triangle also. So that's how we were getting 5 different triangles with that one selection. इसीलिए वो 5 times 65 हुआ था. Okay, now solve this one. Now answer this one. Okay, Harsh has come up with the answer 8C2, 6C3, 4C3. Different answers. Please don't give me different answers. कैसे आया हर्ष? अंकित आप भी बताएं. Zina also says 63. Aditya says 63. Okay, many of you are saying 63 now. Okay, good. In how many ways 3 new cars be parked in 8 vacant parking lots? Yes, 63 is correct. Nice, good. How did you do it? That's nice. 63 is correct. 63 is correct. Into 3 factorial करना पड़ेगा क्या? In how many ways can 3 new cars be parked in 8 vacant parking lots if no 2 cars are parked in adjacent parking lots? Yes, 3 factorial is also required. Good, good. 63 into 3 factorial also, right? Okay, Aditya has used n plus r minus 1 cr minus 1. Aditya formula लिखने में गड़बड़ कर दिया. ठीक है, but anyway. Okay, you are using the spaces part. ठीक है, that's fine. You are using the distribution formula, partition formula that is called, and someone was saying Baggel's formula also in last class, I guess. ठीक है, that's fine. We have not discussed it yet. I think you have done this in your application class. अंकित, आपने क्या concept use किया? हाँ, तुलिका, I understood you are using this. अच्छा, 8 minus 3 plus 1 C3. This is something else. Okay, now listen. हमें समझ गया वो वाला formula use कर रहे हो. A, B, C, A plus B plus C is equal to 8 and gaps. ठीक है, and that's the same, that partition formula. Okay, now listen. Partition formula we haven't discussed yet. We will be covering that up. So अगर इसको basic way में समझें, so 3 new cars to be parked in 8 vacant parking lots. So there are 8 parking lots. So parking lot 1, 2, 3, 4, 5, 6, 7, and 8. There are 8 parking lots, and we are to park 3 cars in any of them, such that no 2 cars are parked in adjacent parking lots. ठीक है ना? No 2 cars are parked in adjacent parking lots. So अब इस बात को ध्यान से समझो. If finally in the final arrangement, let's say this is a car, and this is a car, and this is the third car. So that is a valid arrangement, right? That is a valid arrangement, that out of the 8 parking lots, we have parked 3 cars, and no 2 cars are parked simultaneously. Fine, this is a valid arrangement. So now total how many such arrangements are there? That's what we need to find. Fine, we need to find out how many such arrangements are there. Now let's try to understand. There are various ways to do this. I repeat, there are various ways to do this. तो कैसे करना है, अब बात को ध्यान से समझिए. हाँ, ध्यान से समझिए. How to do this? There are various ways. हाँ, ये काली वाली जो है, ये जो मैंने शेड कर दिया, these are the 3 cars, and remaining are the vacant spaces. Okay, now listen carefully. So in final arrangement, how many vacant parking lots are there? I repeat, in the final arrangement, how many vacant parking spaces are going to be there? How many vacant parking lots are going to be there finally? 5, right? So 5 vacant parking lots are there. Let me write V for them. V vacant parking lot, second vacant, third, fourth, and fifth, right? So these 5 vacant parking lots are going to be there. So we are to park 3 cars. We are to park 3 cars here, right? So when we are to park 3 cars, so between 2 consecutive V's here, can I put 2 cars? Can I put 2 cars in between them? No. Right? No. Between any 2 consecutive V's, maximum 1 car can be parked. Right? Maximum 1 car can be parked. Why can't we put 2 cars here? Because then they will be consecutive. Then they will be in adjacent parking lots. So that is not allowed. So maximum 1 car can be put in between any 2 consecutive V's. So this is 1 space here, 1 space here, the third space, 4th, 5th, and 6th. There are total 6 spaces available, out of which you are to choose 3 to park your cars. I repeat, these are the 6 spaces available, out of which you are to select 3 spaces where you can put 1 car each, isn't it? Because we can't put more than 1 car in any of these 6 places. So how many ways are there? It's clearly 6C3. Out of 6, just select any 3. But because these are 3 new cars, so if we assume the cars to be different, then their arrangement will also need to be done, 3 factorial. And if you are considering them new cars, means they are not having any numbers or something, they're identical. In that case, then there is no need of arrangement. To answer, depending upon whether the cars are different or not, we need to multiply it with 3 factorial as well. Because even if they are new cars, they are having some chassis number or some different differentiating factors would be there. So that's why 3 factorial will also need to be done. Yes, Preetham, arrangement will be there depending upon the things are different or not. And 3 cars are certainly different. They may be of same model, they may be of same brand, but still there are some differentiating factors, isn't it? So that's how we need to multiply with 3 factorial as well. Is it okay? सत्यजीत इज आस्किंग सर थोड़ा वैकेंट प्लेसेस के बीच कैसे होगा समझा दीजिए बाबा मैंने बोला टोटल 5 वैकेंट प्लेसेस होने वाले हैं राइट अब व्हिच पार्किंग लॉट इज गोइंग टू बी वैकेंट दैट आई डोंट नो दैट्स व्हाट वी हैव टू डिवाइस सो आउट ऑफ दिस 5 वैकेंट पार्किंग लॉट्स बिटवीन एनी 2 consecutive parking lots we just figured out देयर कैन बी मैक्सिमम 1 car not more than 1 car because अगर एक से ज्यादा कार आ जाएंगी तो 2 consecutive बन जाएंगी so between 5 vacant parking lots there are 4 spaces and including the end points we have total 6 places so out of these 6 places we need to select 3 places where our cars must be parked ठीक है ना out of these 6 places, we need to find out the 3 places where our cars to be parked. That's how it is 63. And why we multiply with 3 factorial? Because of the arrangement of the different cars. Right? If we assume them to be identical things, in that case, this arrangement won't be there. And if the cars are different, then the 3 different persons need to be arranged also. Okay? Preetham says if identical, if not mentioned, should we use arrangement anyway? In case of identical, there would not be any arrangement. In case of identical, there would not be any arrangement. Why did we not consider 9 for 8 vacant places? Because in that case, we are not to put the 3 cars. After the arrangement, Shubhangi, understand it in this way. Initially, you were having 8 vacant places, out of which 3 are to be filled. Now, after 3 spaces being filled, finally you are going to have 5 vacant places. So right now, what we are doing, we are doing it in a reverse way. We are doing it in a reverse way actually. So 5 vacant spaces are there. So 5 vacant space, and in between we have to adjust 3 cars. In between we have to adjust 3 cars. So we are inserting 3 cars. That's what we are doing. तो 5 vacant spaces के बीच में हम 3 cars लगा रहे हैं. 8 vacant spaces के बीच में 3 car नहीं फंसा रहे हैं. 8 vacant spaces को तो हम यूज कर रहे हैं. उनमें से 3 spaces को हम यूज कर रहे हैं. Right? We are using 3 spaces out of them only. ऐसा नहीं है कि we are having more spaces. ठीक है? हाँ, yes, that's what I said. कि अगर new 3 cars बोला तो cars will be different only. Cars can't be same. Cars are different, na? And rather it depends upon the options also. If options are there, so from the options we can get the hint. And generally questions are not ambiguous in exam. Okay, so for arrangement purpose, we have multiplied this 3 factorial. Otherwise, 63 was fine. Let's move further now. Let's move further. हाँ, internally shuffle कर सकते हैं exactly. ठीक है? I'm moving further now to the next question. In how many ways can 6 girls be seated in a row such that 2 particular girls never sit together? I think that should be an easy question. In how many ways can 6 girls be seated in a row such that 2 particular girls never sit together? Please answer. No, Preetham, arrangement needs to be done there. Arrangement will be done there. Don't worry about that. Row का size है 6 girls. Row का size 6 ही है. Divyansh is saying something. Total place to be. Divyansh, can this be taken as there needs to be 1 vacancy between 2, therefore 8 minus 2C3. Why you are creating new things, Divyansh? Just try to understand. Try to understand what we are discussing. Don't create anything new, please. जुगाड़ की जरूरत नहीं है. Okay, most of you are writing 5C2 into 2 factorial, okay? 5C2 is good thing. You have identified the same thing, but थोड़ा सा गड़बड़ है अभी. Harsh is writing something else. 6 factorial minus 5 factorial. Harsh, थोड़ा सा गड़बड़ है. Okay, let's see. So this can be done exactly in the same way which we did the last question. So 6 girls में से there are 2 particular girls which should not sit together. ना, we should not sit together. तो remaining 4 को तो कोई issue नहीं है. So remaining 4 girls को हम पहले लिख लेते हैं. Let's say G1, G2, G3, G4. And mind that these girls can be arranged among themselves also. Now it is correct. 5 factorial 2 लिखना था Harsh. Now that is correct. Harsh, Yukta, they have done the different way. Yes, we will discuss that also. First, see this here. So these are the 4 girls who have no issue, right? They can be sitting together as well, and there can be some person between them also. They have no issue. But there are other 2 girls. Let's call them AB. So they are not to sit together. So between any 2 such other 4 girls, between any of 2, only one place can be used to make these particular girls sit. इनके बीच में जो places हैं, उनमें maximum 1 girl can be allowed to sit. So as earlier as 1, 2, 3, 4, 5. We have 5 places available, out of which we need to select 2 particular places for those 2 particular girls to be seated. Fine. In 5C2 ways, we can fix up the places. But now the girls can be arranged among themselves in their own places. So these 4 girls can be arranged among themselves in 4 factorial ways, isn't it? And the 2 girls which you have seated on those 2 selected places, they can also be arranged among themselves in 2 factorial ways. So this should be the final answer. Most of you wrote only 5C2 or 5C2 to 2 factorial. But what about these 4 girls? They can also be arranged among themselves, isn't it? So this is the final answer. Now you can simplify also. 5C2 is 10, 4 factorial is 24, and 2 factorial is 2. That comes out to be 480. Fine. Priyanka, it is exactly the same question which we did last. That's why most of the students were writing 5C2. So there are 4 girls who have no issue, but the remaining 2 girls, the 2 particular girls, they don't want to be seated together. ठीक है, तो उसके लिए हमने क्या किया? तो the 4 girls which had no issue, तो पहले हमने उनको लिख लिया है G1, G2, G3, G4, and then between them we have exactly 5 places. Why 5? Because between any 2 particular of these girls, only 1 space can be used for any of the girls. So 1, 2, 3 spaces in between and 1 places at the ends. So total out of these 5 places, we need to 2 for those 2 particular girls. हाँ, सुनो चिंतन, ध्यान से सुनो बात को. तो 5C2 ways में we have selected the 2 places for those 2 particular girls who I'm calling let's say A and B. तो maybe एक place ये वाला select कर लिया, A को यहाँ बैठा देते हैं एक बार, एक place ये वाला select कर लिया, then B is to be seated here. So now we got the arrangement for these 4, arrangement for these 6 person. So A, G1, G2, B, G3, G4. Now G1, G2, G3, G4 can be arranged among their own places in 4 factorial ways, and A and B can be arranged among themselves in those 2 factorial ways. That's how we got this answer. Fine. Now another way. Second way. Many of you have done that. I could see in between. So what is the way? What is the other way? See, if I arrange all the 6 girls together without any constraint, the total ways should have been 6 factorial. Exactly, Abhishek, that's perfectly fine. So 6 factorial is the total number of ways in which any girl could have been arranged anywhere. So now we need to remove those cases in which those 2 particular girls were certainly together. Right? We just need to remove those cases in which these two girls are certainly together. So we did this type of question in the first class. So let's make them 1 unit. उनको 1 unit मान लेते हैं. So 4 girls and 1 unit of those 2 girls, that makes it 5 things to be arranged, which can be done in 5 factorial. And in that single unit of A and B, they can be arranged among themselves also in 2 factorial ways. So this is the basic way to solve the same question. It is 6 factorial minus 5 factorial into 2 factorial. Now that can be solved very easily. 5 factorial we can take out common. So the remaining is 6 minus 2, 4. It comes out to be 4 times 5 factorial. That means 120 into 4, which is 480. So there can be various ways to count. The point is that you must understand the thing clearly. Okay? Yes, Aditya, that's correct. Ritika, good. That's fine. Okay, let's quickly move to the next part now. Next question. What is the number of squares of all size on an 8x8 chessboard? Now that is also a particular variety of question here. So in a square grid or maybe rectangular grids, we have to count the number of squares or number of rectangles. These are various kinds of questions. Okay, 64 are the simple squares, 1, 2, 3, 4, 5, 6, 7, 8. But if you see clearly, if we combine these 4, is it not a square? That is also a square, no? That is also a square of size 2 by 2. So 1 by 1 size wale squares, if you count, that was 64, fine. 8 into 8, 64. What about 2 by 2 wale squares? It is mentioned squares of all sizes. Please see this carefully. Squares of all sizes. So what is the size of squares 2 by 2? Then how many squares are there? Yes, most of you know the answers. Though they are writing directly 204. 2 by 2 wale kitne hain? How do you get to know? Zinab kaise pata 16? Renu, how do you say 16? No. See, 2 by 2 wale, let's count. So this is the first one, right? This is the first one in this corner. Let's count the next one. In this row, can you tell me? In this row, how many such squares will be there? In this row, how many such squares will be there? 7. Hai na? Yes, 49 is correct, Harsh. Good. In this row, how many such squares will be there? See, एक तो ये बन गया. This is first set of 2 by 2 square. Then next, just shift one place. Just shift one place. So this would be the second such 2 by 2 square, right? Second. Then third के लिए फिर से just shift one place. So this will be the third, then fourth, then fifth, then sixth, and then seventh. Is it not? So in this first row, there are 7 such 2 by 2 squares. And how many such rows are there? This was the first row. Then second row would be starting from here, right? Again 7. Then third row would be starting from here. Again 7. So total 7 such rows are to be there. Gunjan wrote perfectly fine. So it is going to be 7 into 7. That is 49 such squares. Got it? Similarly, if you will count 3 by 3 size squares, now can you estimate what it is going to be? 3 by 3 size squares. How many they are going to be? It is going to be 6 into 6. That's true, right? Yes, it is going to be 36 and so on. So you have identified the pattern now. So 4 by 4 size wale, that will be 5 square, which is 25. And then after that 5 by 5 size wale, there will be 4 by 4, 16 squares. And 6 by 6 size squares, they will be 3 times 3, that is 9. And 7 by 7 size squares, that is 2 square, that's 4. And finally 8 by 8 size, that means this complete grid, that is also 1 square. It's 1. So just summation of all the squares from 1 square to 8 square. Summation of all the squares up to 8 square. Summation n square from 1 to 8. So this is the answer here. You can add them up. The value comes out to be 204. Is it okay? Yes, it is sum of all the squares number starting from 1 to 8 square. It comes out to be 204. Do you remember the formula for this? Summation n square. So summation n square is given by n into n plus 1 into 2n plus 1 by 6. So this formula can be used here. Is it okay? Okay, let's move further. So this was to count about squares. Then we are to count rectangles as well. This is clear to everyone, now? All right, let's move further. Same grid. Now this time our target is to find rectangles of all sizes. Rectangles of all sizes. Now see, before counting this answer, I guess Rashna n was 8, na? Now tell me, before starting to solve this, it is asking about rectangles. Are squares to be included in this or not? I'm repeating, I'm asking my question again. Are squares to be included in this or not? All squares are rectangles, so 200 plus something. Exactly, good Anural. Yes, your answer is right, but we need to find the exact value. Yes, so we need to include squares as well, right? When we are to count rectangles, it will be certainly including squares as well. So of course, answer will be 204 plus something. Some of you are saying no, but it is to be included. Remember this, when we are talking about rectangles, so rectangles ka hi ek special case has squares. Squares is just a special category of rectangles. So among the all rectangles, squares will also be included. Now how to count that? That is the issue. How to count that? Okay, now listen carefully. Now listen carefully how I'm talking about. So when we are to create a rectangle, if I'm going to check it size by size, that can also be done. That can also be done. It will take time. As we counted for squares now, same way we can count for rectangles also. There will be more number of cases, but you can get the answer. But now see a better way here. To get a rectangle, you need 2 vertical lines, isn't it? And you need 2 horizontal lines. Listen carefully what I'm saying. To get a rectangle, we need 2 vertical lines and 2 horizontal lines. Fine. And the intersection of those 2 vertical and 2 horizontal lines will give you exactly one rectangle. Can you identify how many vertical lines are available here? How many vertical lines are available here in this 8 by 8 chessboard? Yes, Ashu, that's perfectly fine. By different sizes, we can count that. But it is going to be lengthier part. Although there will also be pattern. But first, try to understand this. That's correct. Most of you are writing that. There are 9 vertical lines. This first line, then second line, third, fourth, fifth, sixth, 7, 8, 9. There are 9 vertical lines available here, right? And same way 9 horizontal lines are also there. So to get a rectangle, we need to select any 2 lines. Yes, that's correct, Gunjan. So any 2 lines, in how many ways can you select? Of course, 9C2. That's what our formula says. We have to select any 2 vertical lines out of the 9 available lines, right? And same way, out of the 9 horizontal lines, we can select the any 2 lines in 9C2 ways. And both the tasks are to be done. That's why it is to be multiplied. So this will give us our answer. 9C2 into 9C2. So what is 9C2? 9C2 is 9 into 8 by 2, right? And same way, other one is also same thing. Just square it. So 2 4s are 8. This is 36 square, which is 1296. So total that many rectangles are available there in this grid. Is it okay? Okay, before moving further, let me ask you another quick question. Now this is a rectangular grid. Okay, now this is a rectangular grid. Assuming all these vertical lines are vertical only, and horizontal are horizontal. So we can see 1, 2, 3, 4. There are 4 rows and 1, 2, 3, 4, 5, 5 columns. Total 20 small boxes you can see here. This is 4 by 5 grid, right? This is a 4 by 5 grid. So my question is, how many rectangles are there in this diagram? In this 4 by 5 grid, how many rectangles are there? total number of rectangles in this grid. Please count and tell fast. Aarti, small things are there. There is no major topic. There are small things we will be covering. So among the vertical lines, if I see, so 1, 2, 3, 4, 5, 6. There are 6 vertical lines. So 6C2 and 1, 2, 3, 4, 5 horizontal lines, 5C2. That's perfectly fine. So 6C2 means 15 and 5C2 is 10. So 150 total number of rectangles are here. Fine. Is it okay to everyone? Understood? Shaurya, ये क्या लिखा है आपने? 4C2, 5C2 plus 1? I don't know. हाँ, ये वाला मेथड स्क्वायर में क्यों यूज नहीं कर सकते? बिकॉज दिस फॉर्मूला डू नॉट नो दैट स्क्वायर के लिए आपको दोनों लाइंस के बीच में इक्वल गैप चाहिए. फॉर्मूला डजंट नो दैट. So while counting the number of squares, we can't make use of this thing. So in that case, we need to count size by size only. 1 by 1 के कितने squares बनेंगे? 2 by 2 वाले how many? 3 by 3 वाले how many? 4 by 4 how many? And so on. So we need to count that way. ठीक है? So while counting squares, we need to use that method only which we discussed. While counting number of rectangles, so this is a faster way, other than counting size by size. Is it okay? Okay, इसमें कितने squares बनेंगे? How to count? Please tell me. You tell me how many squares are there in of 1 by 1 size in this grid? In this grid, how many squares of size 1 by 5, 1 by 1? There will be squares of size 2 by 2 as well, 3 by 3, and maximum will be 4 by 4, right? So how many of 1 by 1 size? So 4 into 5, that's 20, that's correct. 4 into 5, that's 20. How many of size 2 by 2? How many of size 2 by 2? You can see that 1 and 2 and 3, there are 3 such rows, and in every row there will be 1, 2, 3, 4. It will be 3 into 4. Not 10, it will be 12. It will be 3 into 4. That is 12. Isn't it? Yes, 2 by 2 ke 3 into 4. That's fine. Good. Arey dekho na dhyan se. How many rows will be there of 2 by 2 squares? So this is first row, then second, and then third. There will be 3 rows. And in every row we are having 1, 2, 3, and 4 such squares. So 3 into 4, that is 12 such squares. Exactly same way 3 by 3. I hope you have understood the pattern now. So 3 by 3, it will be 2 times 3. That is 6 squares. And 4 by 4, it will be 1 times 2. That is 2 squares. Now you can add them easily. You'll get the answer. So there are 30 squares. Fine. So total there are 30 squares. 31, huh? Oh, sorry, 40. 40. Yes, it is 40. 32 and 8. Yes, 40 it is. Is it okay? Good. So we have understood how to count the number of rectangles or number of squares in any particular grid, right? Be it a normal 8x8 chessboard. So, halanki for 8x8 chessboard, people remember the values. As somebody said, for 204 directly the number of squares and 1296 rectangles. But it can be any grid and we can easily count like this. Okay? Okay, let's move further now. Okay, now this is thing I think Chintan was asking in the last class. This is a small topic, a new thing here. Durgesh is asking 4 by 4 ka 1 by 2 kaise? Arey baba, let's see here. Durgesh ji, how should I make you understand? See, 4 by 4, if I am seeing squares, so this is one square, one such square of 4 by 4. Fine. So its height is 4 only, it cannot be extended. So this is the one such square, and just shift it one step, you will get another one also. Isn't it? You just shifted one place there, you'll be getting 2 such squares. Is it okay, Durgesh? Yes, Preetham, that's correct. So total rectangle means squares plus rectangles of different size. Okay, let's move further. Now this was the question. There are 4 physics books, 3 chemistry and 2 maths books. In how many ways can a person select at least one book of each subject? Now this is a slightly different thing. Now try to understand. Let me go back first. See, tell me, we are discussing about number of different selections possible. Number of different selections. Amongst n identical objects or among n distinct objects. Now this is a short topic here. Now try to understand. I'm taking an example. If you are having 10 red balls, so by default we assume when it is written that all balls are identical. Okay, 10 red balls means all 10 red balls are identical. Fine. Now tell me, in how many ways you can select one ball? In how many ways can you select one ball out of these 10 red balls? Don't rush to the answers first. I hope you have done this thing. Good. Okay. There's only one way to select one ball. One ball select करने का एक ही way है. 2 balls select करने के. In how many ways can we select 2 balls? It's again one way. Right? In how many ways can we select 3 balls? It's again one way. Right? So 4, 5, 6, 7, 8, yeah, all 10. सभी के लिए one way है. And if I'm not to select any balls, that is also one way. If I'm not selecting any ball, that means 0 selection. That is also one way. So if I ask you, what is the total number of selections possible? Total number of different selections possible from these 10 red balls. Number of different selections possible from these 10 red balls. Yes, these are identical red balls. So how many total different selections? It is 11, exactly. Good. That means amongst n identical objects, the number of different selection possible is n plus 1, which includes the case when nothing is being selected. Fine, it includes the case when nothing is being selected. Right, that's clear. And similarly, if there are n distinct objects, let's say there are 10 persons. There are 10 persons. So in how many ways can you select one person out of that? If there are 10 persons, in how many ways can you select one person? If there are 10 persons, so of course persons are different, right? There's no need to write different persons. Persons different ही होने वाले हैं. So in how many ways we can select one person? There are of course 10 ways, which is basically 10C1, right? That is 10 ways. Now we can apply C here. Yes. And if you are to select two persons, then how many ways you can select? If you want to select two persons, then in how many ways can you select? It will be 10C2. Yes, it is 10C2 now. Out of 10 different persons, select any two in 10C2 ways, which comes out to be 45. So no need to write all the values now. So it will be 10C2. Then for 3 persons, it will be 10C3. And so on will go up to 10C10. Selecting all the 10 persons. And if we are not selecting anyone, then how many ways are there? That's also one way, which is 10C0. That's one way. Fine. So again, so total how many different selections are possible from these 10 persons? That is sum of all these values. 10C0, 10C1, 10C2 up to 10C10. Okay, na? And do you know what is the sum? It's 10C0 plus 10C1 plus 10C2 and so on up to 10C10. How much it is equal to? This is equal to 2 raised to power 10. Fine. So this 2 raised to power n is the number of different selections possible amongst n distinct objects, and it includes the case when none of them is being selected. Fine. So this was the short topic here, based on which now we are having this set of questions. Till this part, is it clear to everyone? Okay, now let's come to the question again. So now we are having 4 physics books. So we assume here that physics books are identical. So these are identical physics books. All physics books, same brand, same batch, everything same. 3 chemistry books, again identical chemistry books, identical maths books. Now in how many ways can a person select at least one book? At least one book. In how many ways? Answer this. Total 4 and 3, 7 into 9 books are there. At least one book is to be selected. How to do that? Divyansh is saying all cases minus selecting none. All cases कितने हैं? 2 raised to power 9. But physics books are identical, na? All physics books are identical. They are no different. एक कब बोला कि physics books अलग-अलग हैं? So when it says 4 physics books, so we have to assume that they are identical physics books. As I mentioned, there are 10 red balls. So red balls means identical red balls. Okay, tell me, among 4 physics books, how many different selections are possible? Among the 4 identical physics books, how many total selections are possible, including none? Yes, 59 is correct answer. Many of you are writing that. That's good. There are 5 selections, right? There are 5 selections possible, including none. So there are 5 ways, 5 different selections possible among the physics books. That is 0 book selected, 1 book selected, 2, 3, 4. Right? There are 5 selections possible. Okay, same way among 3 chemistry books, how many different selections are possible? It is 4, including 0 selection. Fine. And same way among the 2 math books, you have 3 different selections possible. So total 5 into 4 into 3, that is 60 selections can be made. 60 different selections can be made from this combination, and it includes the case when 0 physics book, 0 chemistry book, and 0 math book is being selected. That means none is selected. Because we want at least one book, so we need to subtract that one case. Yes, that is the right answer. So 5 into 4 into 3 minus 1, that is 59. So this is the answer for the first part. Right? This is the answer and the solution for the first part. Is it okay? Now coming to the second part. At least one book of each subject. Now tell me the answer. Rashna, why 3 cases to be subtracted? These 60 cases are what? 0 physics, 0 chemistry, 0 maths. After that, next cases, will there be any other case in which 0 of each is being selected? No. Next, it could be possible 0 physics, 0 chemistry, but 1 maths. 0 physics, 0 chemistry, 2 maths. 0 physics, 0 chemistry, 2 maths. Now let's make it different, something different. But there's only one case which we do not want. There's only one case which we do not want, and that case is when all books have not been selected. None of the books have been selected. So only one case needs to be subtracted. Okay, this next one now, second part, at least one book of each kind. Yes, it is 4 into 3 into 2. Good. So directly from 5 ki bajai, we will write 4. So 4 into 3 into 2. That is 24. That is the answer for the second part. Okay. Good. This is not 4C1, 3C1, 2C1, Vatsal. It's not 4C1. 4C1 means out of 4 different things, you are selecting one. It is not to select one. It is select at least one. At least one means select one book or 2 books or 3 like that. So don't do the mistake. It is not 4C1. Halaki 4C1 is 4 only, but here it is not 4C1. It is talking about at least one book, so one or more than one. And also these are 4 identical physics books, so 4C1 can't be applied here. Okay? अरे नहीं, by default distinct नहीं मानते हैं, नहीं, by default कुछ नहीं मानते हैं. We need to go by the situation. Don't forget, I gave you this example here. 10 Red Bulls, they are identical. 10 persons, they are different. That is by default. That is by default. ठीक है ना? So when it says 10 persons, automatically they are different. But 10 Red Bulls, so it is assumed they are identical. By default, we don't assume that everything is to be different only or identical only. It depends upon the situations. So if there are 10 persons, they are certainly different. If there are 10 Red Bulls, they are certainly same. So as in this question, when it says 4 physics books, so it is not mentioned here, but they are all identical. ठीक है? Akriti, for the second part, so at least one book of each subject. It means now for 4 physics books, how many total sections were there? 5. But it included that case in which 0 physics book was selected. But now I want at least one book of each subject must be there. That means 0 physics book wala case should be subtracted now. So it should be 5 minus 1, that is 4. Same way, 4 minus 1, that is 3. And 3 minus 1, that is 2. Now these are the cases in which at least one book of each subject has been selected. That's how it is 4 into 3 into 2. Okay? 5 books of same subject, they are same. यहाँ तो 4 3 2 ही है ना? Is it fine? Okay, let's move further now. Acha, this question. Is it same thing? Or is it same question? Anyway, let's move further. Next one. Indrajit has 2n plus 1 employees in iPointer. The number of ways in which he can invite at least n plus 1 for a beer party is 1, 0, 2, 4. How many employees are there in iPointer? Okay, try to solve this. Have you done this question earlier? Okay, you have not done it earlier. No, don't worry. Now do it. There are total 2n plus 1 employees, and the number of ways in which he can invite at least n plus 1 employees for a party is 1, 0, 2, 4. How many employees are there in iPointer? Okay. Harsh, there would not be any ambiguity in the question. See, if you are saying 5 books may be identical, 5 books may be different also. So there cannot be any general answer for this. So don't worry about these ambiguities. Ambiguities would not be there in the question. And if it is there, that is common for all. That question has to be left. Or we need to judge it by the options. Just saying if 5 books should be considered identical or distinct, there cannot be any specific answer for that. Okay, I'm getting answer for this question. Many of you are saying 19. How are you getting that? Aryan, Aditya Goyal, Abhishek, Zeenab says 9. कैसे कर रहे हो? How are you getting it 19? I don't know the answer. I need to calculate. It is 19 as n is 9. अच्छा, इसको 2 को 10 देख के बोल रहे हो क्या? If you are putting n is equal to 9, I don't know what you are doing. Rutuja, that is the thing. If Rutuja is asking if identical or distinct both are not mentioned, then what to consider? That is the situation. The previous example I gave you, it was not mentioned clearly. That's how we need to understand. And if it is not clear, then leave the question. Don't worry about that. By the situation, we can understand that 10 persons is by default different persons. 10 Red Bulls is by default same Red Bulls. That need not to be mentioned. That's what I just discussed. Okay, see what is happening here in this question. There are total 2n plus 1 employees, out of which he wants to invite at least n plus 1 employees. So he is going to invite n plus 1 or more than that, right? He's going to invite n plus 1 or more than that. So अगर 2n plus 1 में से n plus 1 को ही invite करना होता, तो how many ways are there? 2n plus 1 c n plus 1, right? Or 2n plus 1 c n plus 2, or 2n plus 1 c n plus 3, and so on up to 2n plus 1 c 2n plus 1. Isn't it? And that is given equal to 1, 0, 2, 4. That is the thing. That is the thing. If he's going to invite exactly n plus 1 employees, so these are the number of ways, plus if he invites n plus 2 number of employees, then these are the number of ways, and so on up to he invites all the employees. So this is given equal to 1024. Yes, Akshat? Why are you having this doubt? Okay, so how many employees are there? That's what we need to find. Now, how to simplify this part? How to simplify this part? That is the question here. Yes, ये तो binomial वाला case is exactly. These are binomial coefficients. All these C terms are known as binomial coefficients. Now, how to find this? So let's go for the binomial results only. Just prior to this slide, we discussed that NC0, NC1, NC2, and so on up to NCN. What was this sum? We just wrote in the previous slide. आवाज जा रही है बीच में, ऐसा क्यों? वैभव से ये सीरीज कैसे बनी? सिर्फ 2n plus 1 c n plus 1 होगा. अरे, why are you missing the word at least? It is talking about at least. He invite at least n plus 1 employees. That means n plus 1 or more than that. See, this is equal to 2 raised to power n. That's fine. That's fine. Now, in this case, the earlier ones are not included. So, what should I say? This NC0 and NCN, they are same. You know that boundary values are identical. They are same. Now, boundary values are all identical here. And NC0 is equal to NCN, NC1 is equal to NCN minus N. And we had discussed that NCR is equal to NCN minus R. Yes? Remember this part? We had already discussed that. Out of n things, if you are selecting r things, that means remaining n minus r things are also selected. That is same thing. That value is going to be equal. NCR is equal to NCN minus R. है ना? So same way here, NC0 and NCN, they are same. NC1 and NCN minus 1, they are same, and so on. So all these values are same. Clear? So in this 2n plus 1, when we are writing from 2n plus 1 C0 up to 2n plus 1 C 2n plus 1, total number of terms would be how much? 2n plus 2. And half of that would be n plus 1. So that's what the case is. So this is actually equal to 2 raised to power 2n. It is half of the entire series. Please see carefully. Please see very carefully. Let me take some value. Let me take an example. Yes, 2 raised to power 2n, that is correct. Let's take an example. If I take the value of n to be 5, let's take an example, everyone, please. Let's take an example, n is equal to 5. If I take n equals to 5, so the terms are going to be 5C0, 5C1, 5C2, 5C3, 5C4, and 5C5. Isn't it? How many terms are there? How many terms are there? I'm explaining, Shubh. Please answer this now. 5C0, 5C1, 5C2, 3, 4, 5. How many terms are there? 6, right? So NC0 से लेकर NCN तक there would be n plus 1 terms. Same way here 2n plus 1 C0 से लेकर 2n plus C 2n plus 1 तक total terms would be 2n plus 2. Fine? Okay. And now we have just discussed that first and last terms are same. 5C0, 5C5, that is same. Right? 5C1, 5C4, that is same. 5C2, 5C3, that is same. ठीक है ना? This total sum was equal to 2 raised to power 5. Can you tell me the value of some of these three terms only? That is 5C3 plus 5C4 plus 5C5. Can you tell me this answer? Without calculating the actual values. Without calculating the actual values. 5C3 plus 5C4 plus 5C5, how much it would be? It is half of that. Don't calculate the actual values. Don't calculate the actual values. Yes, it is half of that. Why? Because these three are equal to these three. So this sum is going to be half of 2 raised to power 5. That is 2 raised to power 4. Exactly. It is half of this. Exactly same way, if it had been starting from 2n plus 1 C0 up to 2n plus 1 C 2n plus 1, then this value had to be 2 raised to power 2n plus 1. Isn't it? अगर ये 2n plus 1 C0 से start करके C 2n plus 1 तक होता, then this value would have been 2 raised to power 2n plus 1. Right? So there are total 2n plus 2 terms, but if we are seeing place-wise, so all values are equal. So starting from n plus 1 up to 2n plus 1, so this set of value is simply half of that. It is half of that. So 2 raised to power 2n plus 1 का half कितना हो जाएगा? It is 2 raised to power 2n. So that's how I hope you can calculate the value of n now. This 1024 is 2 power 10. So 2 power 10 is 2 power 2n, which means n equals 5. So n equals 5, it means the number of employees 2 into 5, 10 plus 1. So answer is 11. So answer is 11. Right, Deep? That's correct. So this question was basically based on the application of this binomial expansion, binomial theorem. Okay, Rashna is asking how off. Rashna, x plus y plus z plus z plus y plus x equals 10. Okay, let's take an example. X plus y plus z plus z plus y plus x is 10. Can you tell me the value of x plus y plus z? How much it will be? N plus 1 is not half of 2n plus 1. In 2n plus 1, there will be 2n plus 2 terms. We had seen here, Baba. 5 NC0 से लेकर NCN तक there are n plus 1 terms. So it is half of 10, right? So these 3 terms are equal to these 3 terms. So sum of 2 equal numbers is equal to 10. So the value of each set is going to be half of that. It is 10 by 2. That is 5. Exactly same pattern we had seen here. So when we are starting from NC0 to NCN, so pairwise each term is having equal value. So first half set of values and the next set of half of values are equal. Good, Ashani. Nice. You understood. Anshita understood. Nice. Shaurya also understood. Nice. But yeah, let's move further. So this question was totally mathematical based on expansion of binomial theorem, but it's quite logical. It's not a difficult thing. Okay, let's move further. Now circular arrangement. That's again a small topic here. Manshi ji, how do you know this is rest half? Wait. Manshi ji, I took example of 5C0, 5C1, 5C2, 5C1, 5C2, 5C3, 5C4, 5C5. That is 2 raised to the power 5. And because this n is odd number here, number of terms are even. 6 terms, right? If it had been 11, so 11C0 से लेकर 11C11, how many terms would be there? How many terms would be there? It's 12. 11C0 to 11C11, how many terms are there? Why don't you understand? Don't try to hesitate. If you have understood, then answer. If you have not understood, then try to understand. When I am ready to repeat, what is the harm? Why don't you repeat? Yes, it's 12. So whenever this is an odd number of terms are going to be even, isn't it? So here there are 12 terms. So when it is 2n plus 1 C0 up to 2n plus 1 C2n plus 1, how many terms are there total? How many terms are there total? Wait, I'm telling that Rimjam. So 2n plus 1 C0 up to 2n plus 1 C2n plus 1. Total terms 2n plus 2. Exactly, Chintan, that's correct. Total 2n plus 2 terms are there. So 2n plus 2 terms may say half terms would be n plus 1. Right? Half terms would be n plus 1. Now tell me, the first n plus 1 term starting from C0 up to last, kahan tak aayenge? Till where? What will be the first half of the terms? It will be 2n plus 1 C. How much? N. N it would be. It is starting from 0. It is starting from 0, isn't it? 0, then 1, then 2, up to n. So this is the first half of the set, and the next half starts from 2n plus 1, C n plus 1. And this is a set of value which was given in that particular question. Okay? This was the set of the values which was given in that particular question. So this sum is going to be half of the entire sum. That entire sum was 2 raised to the power 2n plus 1. I hope you understood the process now. Next part we had already done. Is it clear to everyone now? See, my objective is that only there should not be any confusion. अब अच्छे से clear हुआ, भविष्य good. Don't try to skip the things. बाद में कर लेंगे. बाद में कब करोगे? Nice, Vishnu. Okay, I'm moving further now. So let me move where? Okay, we were here on circular arrangement. So now this is also a small but important topic. So whenever we are to arrange some persons in circular arrangement, now in circular arrangement, in all these questions, we are going to assume that all persons are different. Because identical persons, when they are to be arranged in circular arrangement, it is going to be very difficult. So most of the questions, almost every question of circular arrangement will include the persons or the things which are different. ठीक है, which are different things. रिमझिम जी क्या हुआ? पिछले वाले क्वेश्चन में n plus 1 से 2n plus 1 ले जाना था, तो यही तो बताया और क्या बताया रिमझिम? और क्या बताया था? यही तो बताया था. n plus 1 से 2n plus 1 तक there are total n plus 1 terms. Half of the terms. ठीक है, let's come to the circular arrangement now. So in the circular arrangement, so whenever there are 4 persons, let's say you can see A, B, C, D, 4 persons are to be arranged here. See, in all these arrangements, if you see carefully, A, B, C, D, A, B, C, D, A, B, C, D, A, B, C, D. Same A, B, C, D have been just rotated, isn't it? So all these 4 arrangements are same or different? What do you see? All these 4 arrangements, are you able to see it properly? Are you able to see this diagram properly? Rimjim, there won't be any doubt if you will write on your own. कई बार काफी सारी चीजें स्क्रीन पे देखने में कंफ्यूजन हो जाता है. You will write it, you will understand. Are they same or different? They are same. They are same. See, why they are same? Because they are in symmetrical order. Only this, they have been shifted 90 degree. They are shifted 90 degree clockwise, and then again shifted, but it is same arrangement. If we assume the surroundings to be identical, right? If we assume the surroundings to be identical, so for the person A के right में, left में, सब same persons बैठे हैं. यहाँ पे भी, in every case, it is same thing. So they are exactly same. Only the rotation हमें दिखाई दे रहा है, it is rotation, 90 degree rotation in every case. So, but if we take each of the case individually, then they are identical. They are not different. So in circular arrangement case, what do we assume? By default, we assume the surroundings to be identical always, or neglect the surrounding basically. So if we are neglecting the surrounding, then all these 4 arrangements are exactly same. ठीक है? All these arrangements are exactly same. In case of factorial arrangement, अगर हम इनको एक line में arrange करते, if you are arranging these 4 persons in a line, so starting from let's say here, so if I write A, B, C, D, then if I take this A at the end there, so B, C, D, A. If I take B also at the end, it becomes C, D, A, B. And I take this C also at the back there, it becomes D, A, B, C. And if I take D also back there, it will be again same, A, B, C, D. So in the linear arrangement case, all these 4 are same or different? In linear arrangement, same, all these 4 cases are same or different? In linear arrangement, same. All these four are same or different. It's different, right? It's different. But if I arrange them in this order in clockwise, in circular direction, that means let's join them. इसको cyclically order में देख लेते हैं. A, B, C, D, A, B, C, D. Then they are same. If this linear arrangement is arranged around a circle, then they become same. So basically, these four different cases of linear arrangement are identical in the circular arrangement. So that's how every four such cases would be there. Yes, in circular arrangement, that will become same. Right now, they are different. So linear arrangement के हर चार different cases will become identical. They will become one case in case of circular arrangement, as shown here. All these cases only are shown here. ठीक है ना? A is at the top, then B, C, D. Then B is at the top, then C, D, A. Right? Then C is at the top, then D, A, B. Same with then D is at the top, A, B, C. All these four different linear arrangement cases have been shown here. In circular arrangement, that means the four cases becomes one. That means that number of cases becomes 1/4. Right? The number of cases becomes 1/4. Linear arrangement में total how many cases were there for four persons A, B, C, D? It was 4 factorial. But while moving to circular arrangement, it is going to become 1/4 of that. So 1/4 of 4 factorial, or basically 3 factorial. Fine. So in general, the result is that when n persons are to be arranged in circular order, so the number of arrangements is going to be n minus 1 factorial. Why? Because in linear arrangement, when we were to arrange n different persons, number of ways was n factorial. And now each of the n cases is going to account for only one circular case. So number of cases are going to become 1 by n, which will become n minus 1 factorial. Is it fine? Is it clear so far? Although those who have studied P&C earlier, you remember this result, n minus 1 factorial. But without understanding, it will be very easy to deceive you. It will be very easy to trap you somewhere. So don't get trapped if you understand why we are doing that. So because n different cases of linear arrangement becomes 1. So total number of cases are becoming 1 by n times. That's it. Aryan says different arrangements possible, but not as much as in linear. Here, total number of arrangements will be. So why exactly 3 factorial? 4 factorial से कम तो बहुत चीजें होती है ना. So because the number of cases are becoming 1/4, that's why it became 3 factorial. And in general, it becomes 1 by nth, 1 by nth. That's why it is becoming n minus 1 factorial. Yes, exactly, Tulika. That's also perfectly fine. So out of 4 persons, there are 4 seats available. 1, 2, 3, 4. There are 4 seats available because surroundings are identical. So let's say A be the first person. अब A के लिए कितनी ways हैं? In how many ways can you make A sit? So A can sit here or here or here, anywhere. That is same way. Right? There are no 4 ways. There's only one way. Right? Because all seats are identical, surroundings are identical. We are neglecting the surrounding. So for first person A, there's only one way to be seated. Right? There is only one way in case of circular arrangement. For first person, there's only one way to be seated. But the moment this first person is seated, now all these places are distinct. Now all these 3 places become distinct. They become different now. How? Because now A is creating the benchmark. A say left mein, A say right mein, A ke opposite. Now all the 3 seats become different. So now number of arrangements of the remaining 3 persons at remaining 3 places, that is 3 factorial. Fine. So there's exactly one way for the first person, and that first person now creates the distinguishness between the different seats. So that's how we get this answer. So it comes out to be 3 factorial because for the other 3 places, they become different now. So at these 3 different places, 3 persons can be arranged in 3 factorial ways. I hope it is clear. Yes, environment, surroundings, we are assuming them to be, we are neglecting them. We are assuming them to be identical. Okay, so that is a basic way here. And somebody wrote in comments, I saw that regarding the necklace case. See, when it becomes a necklace ka matlab, let me talk on the next slide. First serious question. First question, in how many ways can 8 persons be seated around a circular table? Answer fast. First answer this one, then I will discuss about necklace one also. In how many ways can 8 persons be seated around a circular table? Answer. Yes, it is 7 factorial, good. 7 factorial is 5040 by the way, Shubham. It's not 1440. Okay. Next one now. In how many ways can 10 distinct flowers be arranged on a garland? In how many ways can 10 distinct flowers be arranged on a garland? Is it 9 factorial? Vatsal says 9 factorial into 2. Aditya Jha says 9 factorial by 2. Preeti also says 9 factorial by 2. Yes, it is 9 factorial by 2 divided by 2. Same as I was about to discuss that necklace case or this garland case. So what is happening here? Why we are dividing by 2? Shouldn't it be 9 factorial only? A 2 से divide क्यों किया है? Why we are dividing it by 2? Now try to understand this. Those who know it already, they had remembered this. कि garland के case में, necklace के case में divide by 2 करते हैं. But why? Try to understand this. Tell me A, B, C, D. This arrangement and A, B, C, D. This arrangement. So these are 2 arrangements of 4 persons. A, B, C, D, and this is again A, B, C, D. Are these 2 arrangements same or different? Yes, that's what I'm trying to explain, Tulika. Try to understand. It's not very difficult. And if you understand, then it becomes much easier. हाँ अंकित, perfectly fine, good. Ankit has given the answer. Garland को उठाकर पटक सकते हैं इसलिए, exactly. This here, please tell me the answer. Are these two arrangements different or same? Some of you are saying different. Jitu says different, but Mansi, Kashish says same. Same कैसे हैं? Again, Vedanti says different, but Darshan, Anand says same. Don't you see this is clockwise? A, B, C, D are sitting clockwise here, and here A, B, C, D are sitting anti-clockwise. How it is same? यहाँ पर if A is looking at the center, तो A के left में B है, A के left में B है, और यहाँ पर A के right में D है. But in this case, A के right में B है, and this left में D है. Although neighbors are same, but the directions are changed, na? So they are different ways. Yes, there are mirror images, you can say. So mirror images are same or different? They are different. They are not same. They are not same. ठीक है ना? So there are 4 persons here. So that is different arrangement. But in case of a garland, let A, B, C, D are the flowers. If this is a garland, if this is the case of a garland, yes, so this garland can be rotated. उसको घुमा सकते हैं. Exactly, Tulika, that's perfectly fine. So if it had been a garland, then it can work for both the cases. Only one arrangement, this clockwise arrangement can be used as anti-clockwise also if it is a garland of flowers or some beads, necklace or something. तो इसको उठा के पटक सकते हैं if there are different flowers or different beads. Fine. That's why number of ways become half of that 9 factorial. Is it clear? Ayush says if the question in how many ways 7 people be seated around a circular table which has 8 distinct chairs, how we are to solve this? Okay, good. Let's take it up. So Ayush says there are 8 chairs, 8 distinct places you are saying. 8 distinct chairs सब different ही होगा ना फिर तो? It's as good as a linear. Ayush, it is as good as a linear. Ayush says there are 8 distinct chairs, and they are arranged in a circular order, circular manner. ठीक है? And 7 persons are to sit around it. Everyone, please tell me how many ways are there for any of the first person to take a seat? How many ways are there for any one person to take a seat around this circular table where there are 8 distinct chairs? And how the chairs are distinct? They may be numbered. Chair number 1, chair number 2, chair number 3, and so on. So first person के पास कितनी ways हैं? Okay, many of you are saying 8. Harshit says 1. 1 क्यों भैया? Srinitha, why it is 1? It is mentioned 8 distinct chairs are there. All 8 ways are there. All chairs are different. So first person if sits on first chair or second chair or third chair, that is different. Why? Because the chairs are distinct. So the first person has got 8 ways. What about the next person? 7 ways then, 6 ways then, 5 ways then, 4 ways then, 3 ways then, 2 ways. That's it. It is as good as a linear case. It is as good as a linear case. Is it okay? Exactly. Yes, Akash, that's perfectly fine. Okay, let's move further now. So in case of circular arrangement, why number of ways were decreasing? Because we were assuming all places to be identical and we were neglecting the surrounding. If somehow that is not to be neglected, as in this case, 8 distinct chairs बोल दिया. So if they are distinct chairs, तब चाहे circle बनाओ, चाहे line बनाओ, चाहे triangle बनाओ, how does it matter? They are different. Fine. Okay, let's move further. Another question: in how many ways 5 boys and 5 girls be seated around a circular table so that no 2 girls sit together? No 2 girls sit together. Easy question. Please do it fast. Five boys, 5 girls to be seated around circular table so that no 2 girls sit together. Yes, 4 factorial into 5 factorial. That's perfectly fine. Good. Good. It's 4 factorial into 5 factorial. Why? Because there are 5 boys and 5 girls, so certainly they need to sit alternately, right? They need to sit alternately. So let's say first make 5 boys sit. So there are total 10 seats. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So let's say first make the 5 boys sit. So first boy के पास कितनी ways है? How many ways are there with the first boy? Because surroundings are identical, seats are identical, nothing is mentioned. So we are assuming the seats to be identical. So first boy can take any seat. There's only one way, right? And the moment first boy take his seat, then the seats for other boys are fixed, right? Because they are to be seated alternately. And because this first boy has taken his seat, so the seats become different also. So the 4 remaining boys can be arranged among the remaining 4 seats in 4 factorial ways. And now girl seats for 5 girls are also fixed and they're also distinct, so they can be arranged in 5 factorial ways. So this is the right answer. Okay. And second question, this fourth one: in how many ways can 9 beads be arranged in a necklace such that 3 particular beads are always together? 3 particular beads are always together. Six factorial. That's correct, Vatsal. Vatsal Omar, that's right. 6 factorial into 3 factorial by 2. Good. Yes, Srinitha, that's correct. Listen, see, because it's a necklace case, so we can rotate it also, as you were discussing in the case of garland. So it's the same thing. So this necklace can be used both ways. Now we can rotate it. So let's rotation part be done later. So first, just discuss this part. So 9 beads are there, and 3 particular beads are to be together always. So 3 particular beads are to be together. So that 3 beads set can be made 1 unit. So 3 beads, that becomes 1 set. And beside that, we have 6 more beads. So 1, 2, 3, 4, 5, 6. And it is not mentioned, but we are assuming all the beads are different. Otherwise, there would not be any arrangement. So 6 and 1, 7. So total 7 different things are to be arranged in circular order. So number of ways would be 6 factorial, isn't it? And among those 6 factorial arrangement, these 3 beads can be arranged among themselves also in 3 factorial ways, isn't it? So that becomes the circular arrangement. And now because it is a necklace case, so we can flip it also, we can rotate it also. That's why divided by 2. So this is the final answer. This is the final answer. Okay? Anurag, 7 क्यों होगा? There are total 7 things, na? There are 6 beads and this 1 set. Total 7 things are to be arranged. So when 7 things are to be arranged around the circular arrangement, so the number of ways will be 6 factorial. We forgot when there are n things to be arranged in circular order, n things when they are arranged in circular order, so the number of ways are n minus 1 factorial. Right? It's not n factorial. Okay, let's move further. Next question. In how many ways 8 persons can be seated around a square table which has 2 seats on each side? Now this is a square table. Now this concept will be very clear. So there are 2 seats along each side. Now be very careful. So 8 persons are to be seated. Now tell me, how many ways are there for the first person to take a seat? First person के पास कितनी ways हैं? हाँ, Chinmay, that's correct. It was not mentioned clearly that beads are different. If beads are same, then there would be only one way, na, Chinmay? If all the beads were same, there would be only one way then. Okay, coming back to this question now. So there are 8 seats like this, and 8 different persons are there. For any first person, how many different ways are there? Some of you are saying 8, some of you are saying 1. Sorry, different है क्या? नहीं. We are assuming surroundings to be identical. It is not mentioned. So surroundings we are assuming to be identical, or we are neglecting the surroundings. And this is a square table, so it is symmetrically placed. All chairs are identical. It's not. It doesn't say chairs are different. So we are assuming it is symmetrical arrangement. Is it one way? Please be careful. Some of you, Abhishek Sharma says 2 ways. I'm only asking for the first person because the moment first person is seated, उसके बाद तो सारी ही different बन जाने वाली हैं, isn't it? The moment first person is seated, after that all the seats are going to be distinct with respect to that first person. So I can say again, Abhishek Sharma says 2, Divyansh अभी भी 8 बोल रहे हैं, maximum people are saying 1, Gunjan says 4. Why 4, Gunjan? Or someone, Sanskar, is also saying 4. Why 4? Can you explain? And Shubhangi, why 2? Exactly, Kavya, good. Left wali or right wali? There are 2 ways, not 4. Yes, Nidhi, that's correct. 2. See, let's say first person को यहाँ बिठाते हैं. Please see very carefully. First person को यहाँ बिठाया, first, then second यहाँ, third, fourth, fifth, sixth, seventh, eighth. That is one possible arrangement. Please see everyone carefully. First person को अगर यहाँ बिठाया, first, second, third, fourth, fifth, sixth, seventh, eighth. That is one particular arrangement. Now the same arrangement, if I rotate slightly, let's take first person here. First, then second, then third, then fourth, then fifth, sixth, seventh, eighth. Now tell me, the position of one here or here, is it same or different? They are different, right? But if I rotate it further, I take first person here. And in the same order, second, third, fourth, fifth, sixth, seventh, eighth. Is it same or different? It becomes again same now. Same as that of the first case. Is it not? So only these 2 cases are different. As Kavya Mishra was saying, left to right. So on each side there are 2 chairs. So the first person is sitting on the left side or right side. That makes a difference. That is the only thing. After that, after these 2 different positions, again we are going to get the same positions. Fine. So for the first person, there are exactly 2 different ways to be seated. And the moment first person is seated, after that all the 7 seats have become different. So it's obviously for the 7 persons to be arranged on 7 different places, it would be 7 factorial ways. So answer here is 2 into 7 factorial. Is it okay? Is it clear? So we just need to see how many ways are there for the first person to be seated, because the moment we make the first person sit, and after that all seats are different. So it becomes 2 times 7 factorial. Okay, let's move further. Now that's a new topic and small but easy. Rashna wants me to repeat. Okay, wait. Let's repeat then. Let's repeat. If it is a rectangular arrangement, now tell me. If it is a rectangular arrangement, 3 seats here and 2 here, 5, and 3 more and 2 here. Total 10 seats are there. Now tell me how many ways are there for the first person to be seated. Please be careful. How many ways are there for the first person to be seated? Total 10 seats are there. It's a rectangular arrangement. 3 chairs or 3 seats on the longer side and 2 on the shorter sides. First person के पास कितनी ways हैं? 5 or 3? Some of you are saying 5, some of you are saying 3. How many ways are there with the first person? Yes, it is 5. Arey, first person, if it is seated here, that's one case. If it is seated here, that is a different case. If first person sits here, that's another different case. If first person sits here, that's another different case. If first person sits here, that's also a different case. All these 5 cases are different. But if I make the first person sit here, it will be same as that of this one, isn't it? If I make the first person sit here, that will be same. If I make the first person sit here, that will be same. So there are 5 different ways in which the first person can be seated. So if 10 persons are to be made seated around this rectangular table, so the number of ways are 5 into 9 factorial. That's it. Understood? Is it clear to everyone? Rashna, is it okay? Good. So now I hope you have understood the concept. There can be various variations. You must be easily able to do it. Okay, let's quickly move to the next very interesting topic. And after that, we shall over. So when arrangement, when some are similar and rest are dissimilar. There's a small thing but important part. When we have to arrange certain things, out of which some are similar things, identical things, some are dissimilar, many of different things. So for example, A, B, C, D. How many arrangements are there for these 4 letters in a linear way? If we arrange these 4 letters in linear way, how many arrangements are there? Answer fast. It is 4 factorial. Yes, we have done that many times. It is A, B, C, D. They can be arranged in 4 factorial ways. That is total 24 ways. Fine. But if I make it A, B, C, C, now how many arrangements are there? Now how many arrangements are there? A, B, C, C. Now how many arrangements are there? 3 factorial into 2. It's become same thing. Basically 4 factorial by 2 factorial, right? It is 4 factorial by 2 factorial. Good. Kyun? Why? I'm sure again you remember this. दो same हो गए तो 2 factorial से divide कर दो, 3 same हो गए तो 3 factorial से divide कर दो. But why? Why it is happening? Why it is happening 4 factorial by 2 factorial? Because in any particular arrangement of this A, B, C, D, let's take maybe A, C, B, D was an arrangement and A, D, B, C was also an arrangement. So when C and D are on same places, but they are shifting among themselves, when they are switching among themselves. So these were 2 different cases in this arrangement. But now in this case, both C and D have become equal. Both C and D have become equal. So their 2 arrangements among themselves have become identical. Their 2 arrangements among themselves have become identical. So that's why we need to divide by their number of arrangements. They become same. So it comes out to be 4 factorial by 2 factorial. Fine. One more example. Tell me A, B, B, B. How many arrangements would be there? How many arrangements would be there? Subhajit, no problem. Now it is about to over. In just 10-15 minutes, we will be finishing it. Anyway, you can still do some practice or learn something. Answer this one now. Yes, it is 5 factorial by 3 factorial, 2 factorial. So conclusion is right. If all 5 things would have been different, so arrangement would have been 5 factorial. But because these 2 things are same, so their mutual arrangements would become same now. So we need to divide by 2 factorial and same way divide by 3 factorial. So that becomes the answer. Okay. Now there can be one more way to think. Now listen carefully. In the same scenario, there can be one more way to think. Please listen carefully. We are having 5 places. 1, 2, 3, 4, 5. Fine. Listen carefully. I'm talking about the same thing only. There are 5 places at which we are to place these 2 A's and 3 B's. Isn't it? Isn't it? Now tell me, Srinitha, we do not want the 2 A's to remain together. They can be separated also. There's no problem in that. We consider them as one unit when we want to make them together. We want to keep them together. But right now, there is no such condition. Right now, there is no such condition. Okay, na? Okay, now listen here. So these are 5 places at which we need to place these 5 letters A, B, B, B. Okay. Now, at which 2 places I can place 2 A's? In how many ways can I select the 2 places where to put the 2 A's? Please tell me. I repeat my question. In how many ways can I select the 2 places where I can put the 2 A's? Tell me the answer. Yes, 5C2. Good. So in 5C2 ways, I can select the 2 places. And where what I'm going to do, I need to put 2 A's. Is there any way to arrange them? No, that's one way. They're identical. And what about the remaining 3 places? What about the remaining 3 places? There we need to fill B only, in again only one way. Fine. So this answer is nothing but 5C2, which is same. 5 factorial by 3 factorial, 2 factorial. Is it okay? Understood? Yes, Tulika. So in 5C2 ways, we have selected the 2 places where I'm going to put, where I'm going to arrange these 2 A's, and the arrangement way is only one. And at the remaining 3 places, we just need to put the 3 B's because they're all identical. That's it. Understood? Good. Yes, it is same way. Abhishek, you can do 5C3 also. It is same thing. It is same thing. Okay, now these are some basic easy questions. I am sure you can easily do that. Let's quickly move further. Ranking of a word, that is also easy part. I hope you can do it. Then some grouping. Grouping we will do next time. Yes, grouping we will do later, not today. You can solve this question right now. This is the last question for the day. Grouping we will do later. Please solve this question. Tulika, that part will be doing later. That will come in the grouping and distribution part. That thing will come when we'll discuss grouping and distribution part. So we will not start it right now. There's no much time available now. Right now, solve this one. Ranking of a word. If all the words that can be formed using all the letters of the word quant are arranged as in dictionary, then the word on the 25th rank will be, and what will be the rank of the word quant? Solve these two questions. Yes, arranged as in dictionary order means alphabetical. That's correct, Deep. Yes, these types of questions were there in your classes 11th and 12th. That's true. This whole topic was there only. Till 10th class, you have not studied this topic, but it is a very interesting topic. Okay, let's see all the words that can be formed using all the letters of the word quant. All letters are different here, so that's not very difficult. So 1, 2, 3, 4, 5. So total 5 factorial, that is total 120 different words can be formed by rearranging all the digits, all the letters. Now, first question is the word on 25th rank. So the first initial words will start with letter A, yes or no? Because A is the earliest letter in alphabetical order. So the word starting with A will be having first place will be with A, and then remaining 4 places can be arranged in 4 factorial ways, isn't it? So 4 factorial, that is 24. So 24 are gone. We have to look for the 25th. So A ke baad, next the words, they will start with which letter? Q, U, N or T? N is the earliest one, that's true. So N, and we have to look for the 25th number. So that means we have to look for the first word which can be starting, which is starting with N. So after N, it would be certainly A, and A ke baad it will be Q, then T, then U, right? Okay, that was an easy question. And then this last one, what will be the rank of the word quant? So first A wale 24, then N wale 24. After that, it is turn of Q, and Q maybe sabse pehle will be having Q A. So these remaining 3 places can be filled in 3 factorial ways, that is 6. After that, Q T, again 6 more, and then we'll be coming to Q U. And among Q U, first it will be A only, and then N only, and then T only. So these many plus 1. So 24, 24, 48, 48, and 12 is 60 plus 1. So 61 is the rank of the word quant, isn't it? Did I miss something? कुछ छोड़ दिया क्या? अच्छा N रह गया ना? हाँ, I missed N. A के बाद पहले N भी आना था. QN. There will be 6 more, right? 67 it would be. Right, I missed QN. Fine, that's correct. So QA 6, QN wale 6, then QT wale 6. After that, we move to QU. So that is the first word starting with QU. Vineet, we are finding the rank of the word quant, so we are making all the words possible. So starting with A, if first place is filled with A, then remaining 4 can be arranged in 4 factorial, that is 24 ways. Same way N, starting with N, there is again 24. Then starting with Q, Q ke baad next first letter would be A, so then remaining 3 places can be filled in 3 factorial or 6 ways. Then QN, again 6 ways. QT, again 6 ways. After that, we are coming to QU, and among this QU series, the first word is this quant only. So 24, 24, that is 48, 24 plus 6, 30, and 30, 60, and 6, 66 plus 1. That makes it 67. So this is the answer. Aditya, by just adding them, you will get the rank here. Okay, so we shall end it here. So grouping and distribution part we will be doing the next session. So let's end it for the day. So thank you very much. I hope some of your concepts may have become clear. Shortcuts I don't prefer. Iska shortcut hota hoga, pata nahi. I don't know. No need of remembering so many shortcuts or something. I don't prefer. Okay, so let's end it here. So any feedback, comments, suggestions, anything you wish to, you can. Thank you very much from my side. This is over for the day. Good night. Thank you very much. I wish that you may have gained something from this session. Good night everyone. Thank you. Okay. Yes, all concepts are brushed. That's nice, Tulika, good. Thank you everyone. शुभंगी आई क्वांटा वाले क्वेश्चंस का फाइनल आंसर बता दीजिए. कौन सा क्वेश्चन था? अच्छा वो नंबर ऑफ एम्प्लॉइज वाला ना? That was 11 ना? Answer was 11 there, शुभंगी. That answer was 11. Yes, we got n is equal to 5 in that case. Yes, Diksha, thank you. Hare Krishna. First question, will you explain again? Which is first question? अच्छा, you're talking about that geometry one. Don't worry, it will come somewhere. We will discuss, no problem. CAT में यही level होता है ज़्यादा tough. I have shared some questions of CAT. CAT never prefer to use any formula. CAT generally asks those questions which can be solved logically, or At most, if you have to use any formula, that's limited up to NCR only. That's it. आपकी VARC कैसी है? VARC I've never studied, but I score nice. I score 80. Minimum 80, above 90 also I have scored 9 times. Close to 90 only, between 80 to 90 somewhere. ठीक है. I think tomorrow also we are having a session. No? I think tomorrow there's some LRDA session.